Greetings. So in this video I'll be putting together the DSO068 from DIY KIT. So what I've got the main board mounted in the little helper thingy-majig that I've cobbled up some time ago. I've got most of the passives over here. That was one of the bags. The rest of it I've still got over here. Good idea when you're putting stuff together is to start with the really smallest stuff, so resistors, small diodes, and so on and so forth going first, and then you start building up bigger and bigger components. Now that I've got still the switches in here, they're not soldered but they're sitting quite snugly in the board, so I left them to it. I don't want to pull them out just to put them back in. They're not in a way so they can be there. Yeah, so let's begin the assembly. Now this is I'll be using just my soldering iron chisel tip, and I've got some 0.3mm solder, which is just gonna come handy. If I can just find the beginning, there we go. So I'm trying to use the really thin solder. It just makes things a whole lot easier. And I'll be this has got to be assembled in two parts. So first, looking at the parts list over here, all of this has to be mounted onto the board, and at this point you've got to do the power up test. So if all this is, you can go through the flow chart, and if you get to this page you can continue with the rest of the stuff, and then you'll do the rest of the initial start. Okay, I figured the easiest way to do this is going to be use the component tester, because those little quarter-watt metal resistors on the blue color, they're horrible to read. You can't really work out the colors on them, but this is easy enough to operate, so I can just stick it in and it will tell me. You probably can't see it on the camera, but that's 3.3K. So looking at this, 3.3K is resistor R10 and R22. So I should be able to find R10 and R22 somewhere. 11 R8, R11, R10, there we go. Yeah, I'll probably not record the whole thing, but you get the idea. It's quite simple enough. Just follow the thing. One thing worth noting, probably, as you put the components in, it's worth ticking them off that you've actually put that component in. It's easy to work out whether you're not missing any component and whatnot, because then when the whole board is populated, it's quite easy to miss out just one resistor, one capacitor or something small. So it's worth ticking them off as you go along. Okay, and I've got all the through-hole, or rather all the axial through-hole parts, so transistors, inductors, and also resistors, inductors, and the diodes. And let me just take it out of here. It will be easier like so. I'm just going to make sure all the leads are bent out in a way that the components are held securely in place. And I've got the board around upside down, and I made sure that nothing falls out, so I can start soldering peacefully. Yeah, soldering iron. One thing to note though, have to be careful around here where the switch contacts are. You don't want to get definitely any solder on those, because it'll be impossible to clean off afterwards, and yeah, may impact the way the switches are working. But yeah, let's just begin the soldering. And that should be all of them. Okay, that's all soldered up. So we've got a ton of resistor leads, and the next thing would be to take this out of the out of the holder, turn it around, and install all the ceramic caps. So those are going to be the next through-hole parts, and yeah, there isn't too many of them. And ceramic caps are quite easy to read. Basically, most of them have got, I'm sure if you can see this to focus, like this one says 104. So basically they all have like a 3-digit marking on them, and basically what it means, the first 2 digits is you take the first 2 digits and add however many zeros there is on the last digit, and that would be your capacitance in nanofarads, well, picofarads, sorry. So 104, it's 1 0 and 4 zeros, so that's 100,000 picofarads, so that's 100 nanocap. And likewise, something else that's got just 15, so that would be 15 picofarads. 104 again, 100 nano, 100 nano, so a lot of those are 100 nanos actually. This big one is 104 as well, 100 volts, so also 100 nano. Here is a number 1 capacitor, 1 picofarad. Okay, anyways, just like before, we'll take the parts list, make sure that we're installing all of them, and go one by one and get them stuck into the right holes. Yeah, there's it's calling for 12 100 nano capacitors, so there's quite a lot of them. So yeah, let's get on with that. I will be actually still double checking all the caps, just because I've got this thing handy, the component tester thing. It's just easier to avoid a faulty part like this rather than looking for it later on. At least when I put it together, I'll be 100% sure that all the components were good. Okay, interesting thing here, this component tester thingy that I've been using. I stuck a 15 picofarad cap and it's trying to test it, and it's saying no unknown or damaged parts. So this is probably reaching the bottom end with what this thing can do. I mean, when we're down to tens of or single picofarads, that's a 3 picofarad capacitor, and no, it still doesn't recognize it. So those component testers, for the very little capacitance, because of the way it's made, this is basically down in the noise of the measurement, so it can't measure it out. But yeah, it's very unlikely something to be wrong with those, but yeah, thankfully they're nicely marked. And all the caps are in, so the same thing again. Oops, take the board out, bend the leads over, and we may begin soldering. Okay, I've got all the caps done. So this is where we are right now, and yeah, time to have a look at what goes next. So I'm all the way down to here. I've got to do up to here, up to this part on the list. This is what I need to get soldered before I do the first test, and then the LCD goes on and the rest of the whatnot. So this is the next batch of the parts, and this little plastic thing, which I initially thought it's some sort of light pipe for the case, it's actually a tool to mount those board-on-board daughter boards, little things. So I'll get to that later. But yeah, let's get all the electrolytic caps and the rest of this stuff stuck in, and we can do the first power up test. This is all pretty much done. So as far as components, actually, so I need to get the little board-on-board things soldered on, and this little plastic thingy majig. So what this is meant to be used for is to hold the board like so when you're hold on, this will go like this, I think. We'll double check, but you get the idea. So this will this can hold the board upright at right angle during the soldering. So then you can, oops, it's a little bit fiddly, yeah, it will hold the board so it doesn't fall over like so. So yeah, what they're saying is to apply a little bit of solder to one of the pads on the board and on the main board, on the dot board and the main board, and then using that tool, hold it upright, and once it is in the right position, then you can remove the tool and solder all the rest of the joints. I have the board here, one of them, and this is meant to go on like this. So I've applied a little tiny bit of solder over here, and a tiny bit of solder on onto the corresponding pad. And now using the little tool to hold it, yeah, that tool is a little bit fiddly, but it does help, I guess, a little bit. So once I've got everything aligned, I can just, while holding this, I can use the soldering iron and make a joint. Actually, I'm thinking this whole tool thingy magic is useless. But okay, I'll try the next one without it, and we'll see how that goes. But yeah, that's once that's being held in place with one of the pins, I can solder all the remaining ones, and like so. This is connected now. Now, for a good measure, in joints that are accessible, this is not necessary, but I think it would make sense to solder it on the opposite side as well, because just for mechanical strength, just to help out a little bit, because if it vibrates out, those joints are quite easily cracked. So if it's connected on both sides, it should be a little bit more stronger, if you know what I mean. So yeah, there is a bead on opposite side now, so this board is now connected and rigid. So yeah, I'm gonna do the next one. I'll probably try it without that nonsense little thing, because from what I can tell, it's useless. But okay. Just worth a note, to identify which way round the board, the daughter board should go on the main board, one of the pads is square, that indicates pin 1, and also one of the solder points on the board is square, that also indicates pin 1. So you can yeah, you can identify which way things go. There's a R32 resistor over here, and that's not been supplied, and I haven't read out, but I think that's got something to do with battery charging. So I'll find out later on. But for the time being, yeah, I'm just gonna apply a tiny bit of solder on both boards, and hold it like so. Yeah, that's easy enough. Is that straight? Yeah, more or less. So yeah, easy enough to do without the little plastic, which just makes things a little bit more fiddly. I'm noticing that a lot of the edges on those little daughter boards are not exactly straight, which then when you put them on the main board, it creates a gap, because the edge of it is not flat, it's kind of rounded. So what I did is a couple of slides with a knife, like so. Makes them flat. You could also use a piece of sandpaper and just do a few rubs on the flat surface, but this seems to be doing the job. You can hear the glass fiber in the FR4 screeching under the blade, but yeah, that makes it flat enough so then it's easier, doesn't wobble so much. And here it is, everything up until the first test power up is soldered on. So yeah, let's do the power up test and see what happens with this. Okay, so to do the first power up test, we've got to double check there is no missed or cold solder joints. Check. Make sure Bob 3 and 5 have been installed. Check. Close JP2 for the time being, even Bob 3 is installed, and keep JP3 and JP4 open. So slight confusion here. There's also JP9 on the board that says this jumper should always be closed, and that's the one over here. So I'm not sure whether to close it before the test or not. I'm struggling to find anything on here that explains whether to close the JP9. But it does say on the other side that should be always closed, so I will close it. So JP9 to close, and close JP2, and those things are, maybe let me zoom in a little bit, and those things are just little tiny solder joints, solder pads rather, that you can just connect with just a blob of solder. There you go, like so. That's JP9 closed, and I'm supposed to close JP2, which is here. Okay, that's done. Going by the diagram over here, it's USB powered. Close JP1, if not, no BOB2. We've got BOB2, so we can keep it open. Power up, check voltage at +5 test point. Is it +5? Where's +5 test point? So let's see, let's power it up. Okay, I've seen a blink somewhere. The LED on the charger circuit just barely glows. So let's just keep this as a negative, and let's see, what do we get? 489, 490. There is a V plus and VS1. Those two are showing the correct voltages, so so far so good. Okay, the next thing is to power it off, which we did, and close JP4. And what is JP4? Oh, that's the connecting point of power supply to the rest of the circuit. So I think what we're doing, I'm deducing, that we've verified that power supply is okay. So now we can close JP4, and that will power up the rest of the, it will put the voltage across the rest of the circuitry. So put a nice blob on there. Yeah. And let's power up again. Oh, we got blinky. And we can press this. So press switch 12. Do you see LED blink once and then twice? So press it once and then twice. So far so good. Excellent, eh? Yeah, the charger circuit has got a little LED, but we'll get to that later on. Can do that one more time. Blinky once, blinky twice. So far so good. So we can proceed to install the front face of the contraption. Here is the progress. So that's pretty much the lot soldered on and ready to go. The last thing left is the LCD to mount it on the back over here using the supplied header. And yeah, I've decided to mount the ICSP headers for both, even though even when I look on the pictures and whatnot, those headers are not mounted on the board. But I think once I put the LCD in, it will be difficult to solder it, and there might be a reason for me to get this to use this in the future. But yeah, so better to solder it now than later. Now I don't quite like the way the LCD is mounted over here, because there is just not enough clearance between the boards. This is literally like so, and yeah, I think that's asking for trouble. So I'm gonna be putting some insulator in here between the LCD and the rest of it, so we can so I can at least be sure that it doesn't short out to anything. Okay, time for the display, and the display should be sitting on, according to the instruction, just on those headers that are not soldered in just yet. But as you can see, once it's on, it's really close, and that's just, yeah, I think it's, as I said before, it's asking for trouble. Especially you've got those metal tabs on here that are quite sticking out, and I think it's a very minute gap between the screen and the main board. So what I thought I will do, and I will go ahead with that, I've cut out a piece of plastic from an anti-static bag that wasn't the conductive one, just static dissipative bag. So it's not conducting, but yeah, I've cut it out so it sits. It will sit like so between the screen and the board, and between the pin headers, and this way there's gonna be an isolation layer between the screen and the rest. So I think if I do it this way, it will be just that little bit, just a little bit safer. At least I will be a little bit happier with it. So yeah, this is what I'm going to do. Just keep that thin piece of plastic in between the screen and the board. I'll probably have to cut it out a little bit less over here because it's going onto the keys, but it's being kept in between the switches and the rotary encoder, and that kind of stops it from moving around. So yeah, I think I'll just make a small markings on here, cut it around the where the contacts are for the switches, and that should be it. Okay, that is soldered in, and a good tip when soldering long pin headers like this is to use basically what are they meant for, the LCD in this case, just as a jig to hold them in place while you're soldering. It makes it all that much easier. And yeah, this whole LCD setup over here is probably the biggest drawback for me over here. In case I need to get back underneath there and you know, tidy up a joint or change a blown component, that means I'll have to desolder the entire LCD, and that's got quite a lot of that has quite a lot of pins to desolder. So yeah, I would have much preferred a socket over here, and I don't think that would have been that much of a cost or an issue to get it implemented. So a socket would have been a million times better, but this will do, I guess, provided nothing breaks. This should do just fine. Okay, and this is finished now as far as the board goes, and this is what it looks like. Yeah, so now I think I'm gonna have to start putting this into the case and get the BNC connectors attached and figure that out. I've already noticed that there is a slight problem with the case, so I'll see what I'm gonna do about that. So this is meant to go in like so. So first you have to slot in the power and the USB connectors, and this should be able to fall down into the case. But if you look from the front, this is where the problem is. So this is at too much of an angle for this basically to do the drop. So I'm not sure yet how am I going to solve that problem, but I'll let you know in a moment. Okay, let's do the power on test 2. So, and JP9, yeah, JP9 I've closed before, so let's power it up and go step by step, see what it says. Okay, so LCD backlight on, yes. Adjust contrasts, can you see display? I can't see anything, to be honest. Oh, now I see. Now I've overdone it, so come back out the other end. There you go, she's alive. Press the button, do you see reaction on the screen? Well, I can do this, but let me see if I can just use this tool. Yes. So is AV plus normal, about plus 5 volts. Is V minus normal? Where is V minus? Yeah, minus 5 volts. That's plus 5 volts. Oh. Okay, AV plus 5, AV minus, minus 5, all good. Okay, set switch 1, 2 and 3 to ground, 10 millivolt and times 1. So ground, 10 millivolts and times 1, yeah. Is V2 measured at 0 volts? Where is V2? Yeah. Yes, it is. Is V3 measured at 0 volts? Yes. Is V4 measured at minus 1.4 volts? 1.6. 1.6, sorry, yeah. And adjust V position. Can you see trace displayed? Yes. I can see the trace on here. Okay, this is my solution to the problem with the case being a little bit tight. So I took a knife and I kind of scratched off on the bottom of a little bit of the case. It doesn't affect the front looks whatsoever. It's still round hole. And then the encoder, I took a file, and this is soft aluminium, and it was quite easy just to file off. You can see a little bit of one edge, so I need to make sure this is in the right position before putting it in, and then it kind of fits with a little bit of wiggling. There you go. so that sits in here, and that won't affect anything because the knob goes on top of it anyways. But yeah, that's almost done. Ever so closer. I need to attach the BNCs now. Okay, time to adjust the compensation caps, those two over here, to make sure the signal is displayed properly. Now, according to the instructions to do that, I've connected the output from here, that's the output of the signal generator, into the analog input. Maybe not. Oh, there you go. So you can see this should be ideal, perfect square wave, but it's not compensated correctly. So I'm not entirely sure which cap is to do with what. So I'm just going to experiment and see what happens. Okay, after a little bit of fiddling, this is as square as I can get it. So we'll leave it at that. Okay, I've now connected the BNCs over to the board, and there was a supplied short strip of concentric cable, and I used that to connect the test signal output, and oscilloscope input, as in instruction, is connected with just two bent cut-off resistor legs that I've had from before, and those go to the points on the board, and that's pretty much completed. Now, what I want to do also before I fully close this up is to install the battery. Okay, and with an old Nokia battery connected to the cable, it works. And one last thing is to see if it will charge, and well, the LED comes up on the charging module. That's safe to assume it's charging the battery, and I think that's it. So probably what I'll do, just put some double-sided tape on here, stick the battery on, put this together, and that's done. Okay, there you go. That's complete complete build, and yeah, that was fun to make. So what I'm going to do now is get this video up, and I'll see what I'll do next. I'll probably need to do some tests and see how this thing performs within its spec. But yeah, so far, as I said, so far so good. Nice little kit for reasonable price, and apart from being a kit to put together, it will be quite a useful piece of equipment to have around. So yeah, I hope you enjoyed this video, and yeah, subscribe for more. For the time being, take care.